Alright, let's go ahead and get started with unsupervised learning. So in previous lesson we had seen supervised learning, in which we had the target label. But in unsupervised learning we do not have the target label. So we have just input and we try to find out the pattern. I mean to say that the algorithm try to find out the patterns in unsupervised learning. So the moreover it does the interpretation, this algorithm does the interpretation, and then finally it do the clustering of these data. Now you see there are three kind of the data which are mixed together. Then these three data got actually three clusters here. You have here the lightest color, the darkest one, and this one a middle darker one kind of. Alright, mid-level darkness is there. So all these three type of the data is mixed there. But we do not have the target. If we have here the multiple, as many as type of the data we have here, so we can have those data types there. But in the target output in advance we don't know how many clusters are there. But with the help of the algorithm we try to find out the similar clusters so that we can perform our algorithm on those similar clusters. So this model is trained using unlabeled data, something like this. The goal is again to identify the patterns and the structure in the data without specifying the target output. Because in unsupervised learning anyway we don't know how many clusters are there and what are the patterns there. So no label data is used to guide the model, allowing it to uncover hidden patterns in the data. So the examples for the unsupervised learnings are these, like we have the clustering, association rule learning, dimensionality reduction, anomaly detection, principal component analysis, k-mean clustering, hierarchical clusterings, and density based clustering. So this clustering is a simple kind of the clustering. So these are the part of the clusterings there, which divides the data into the groups based on the similarity of the data. So if we find out the similarity of the data based on the color, then it says that these data type have the same color. That is how these data are clustered as a single cluster, and these have the same kind of the color. That is how these are clustered as the single cluster. Suppose that if you have here the data which includes the male, female, and neither male and nor female. So these three clusters you can cluster based on the gender of the data. You can find out that there is the male, female, and neither male or female. That means the third gender you can include there. So in association rule we try to find out the relationship between the variables. Alright, so how the relationship, suppose that in recommendation system these kind of the things are used there, where we try to find out the association between the two items there. Suppose that you are buying there the apple and the banana and the pomegranate and so many other fruits there. So based on your buying behavior, it can find out that what is the best recommendation. If you buy the banana, so what will be the next product which you are gonna buy. So that dimensionality reduction is also unsupervised learning. Suppose that you have the data which is kind of 300 dimensions, but you cannot visualize that data. So you convert, or you can say that you project that data into kind of the 2 or 3 dimensions so that you can visualize that data properly. Otherwise, sometimes dimensionality reduction also increases the accuracy. It increases the speed of your model training and the prediction, as well as it reduces the space taken by your data and the model. So there are fourth application, the anomaly detection. So if you do the grouping of the data together, so all similar kind of the data will be grouped together. So whatever the falling outside the group, we can say that those are the outliers. And so this principal component analysis is the part of the dimensionality reduction. There is another kind of the algorithm also known as, which is the LDA. So those kind of the algorithm are used to reduce the dimension of the data. And as I told you earlier that these three type of the data are part of the clustering technique. So these are the some kind of the clustering technique like the k-mean clustering, where it try to find out the group of the data based on the similarity. So it try to find out the distance between the data from the the group of the data, and then it makes the clusters there. And then again we have here the hierarchical clustering. So in this clustering, we try to make a top to bottom approach or bottom to top approach. You can say that in these clusterings we try to make first one clusters, and then we try to break that into the 2 clusters, and then 3 clusters, and the 4 clusters, something like that. We keep breaking it until it converges there. In density based algorithm, we try to find out the maximum density in your algorithm, then it follow that density so that it can make the clusters there. So the differences between these algorithm and these algorithm is that when your data is distributed in non-linear plane, then density based algorithm works there, better. But in linear space, maybe your k-mean clustering algorithm works better than the density based algorithm. Again, depending on your data set, you can choose a right type of the clustering algorithm. Alright, this is all about in this lesson. I'll see you next one.